All right, let's look in. This unit is very straightforward because we're mainly going to look at the different protocols of how to carry out certain tests. And as long as you know those different tests and how to carry them out properly, you're good to go. If you want to unlock those top marks, the main things you want to highlight consistently is you want to justify your choices. So don't just say, I choose this test because it's good, because it exists. You want to say something like, I chose this test because it validly matches the component and the sport. And when you're running tests, you want to run them like a professional. So you want to follow the correct protocol, use the correct unit, have it under the correct conditions, have a warm-up, focus on safety, and be very accurate in your recording. You want to also interpret your results properly, so comparing your results to normative data and explain what they really mean for performance. And you want to give feedback that leads to improvements, so giving strengths, weaknesses, and clear recommendations. I briefly referred to the term validity, but what does validity actually mean? Validity means that the test is actually measuring the component of fitness you say it's measuring. So if a test isn't valid, the number you get is basically a fake confidence boost or a fake panic if it's the negative number. The simplest way to explain validity is if it measures the right thing, it's valid. If it's for the right person, it's valid. If it's in the right context, it's valid. And validity in sport, some examples you might want to know. Let's say we're looking at a 12-minute Cooper run, which is useful, obviously, for developing aerobic endurance, even though it's not really sport specific for a power athlete. So in that case, the results might not be valid for a power athlete. Or for example, in a 30-meter sprint test, the results can be valid for acceleration or speed, but less useful for a marathon athlete. So you always want to be asking, what component am I testing? Is it strength, power, agility, aerobic endurance? Does the test match the movement and the energy requirements of the sport? And does it match the performer's level and their safety needs? So we've looked at validity, let's look at reliability. Reliability means if you repeat the test properly, you should get a similar result. A result can be valid, but not reliable if the conditions are messy. Some ways to increase reliability before the test, pre-test, are to calibrate the equipment. So this could be calibrating a stopwatch, a dynamometer, a timing gate, or the scales. You also want to standardize the warm-up. So keep the same duration and intensity. You want to also practice the technique so that the test isn't ruined by confusion. Now, ways to increase reliability during the test is ensure that the tester must know the protocol properly and also stick to the protocol. So you want to have the same start position, the same rest time, the same instructions, etc., etc. You also want it to be done under constant conditions. So the same type of surface, the same temperature, the same footwear, the same time of day even. And lastly, you want there to be appropriate rest between tests, because if the athlete gets fatigued, then this can destroy the results. Now let's look at practicality and suitability. Practicality can be affected by factors such as cost, time, equipment, and facility. So for example, VO2 max lab tests might be brilliant in a scientific research context, but if you want to conduct it with students in a school, like 25 students, it's not really practical. And suitability means, does it match the sport? Does it match the performance fitness level? And is it safe for their age/their needs? So for example, a 1-rep max test, which we're going to look at further on in this video, can be risky for a beginner who has poor technique and who isn't used to doing 1-rep maxes. So a sub-max strength test could be more suitable for someone like that. Ethical issues. This has to do with testing people safely, legally, and respectfully. So some key ethical requirements that you have to know is informed consent. So the people agree and they understand what the test involves. And also, reasons for terminating a test involve anything like pain, dizziness, if someone is using unsafe technique, or if someone is under distress. Some pre-test preparation methods is to have appropriate rest, no exercise before the test, appropriate hydration, and also a suitable warm-up. And some data protection recommendations or requirements actually are to record results properly, to keep data confidential, and to store the data securely. You also want there to be ethical clearance. So the right people should have permissions and approval in organized settings. And lastly, you want to monitor welfare of the people conducting the test throughout. So monitor that they are safe and stop the test if needed. All right, now let's look at fitness tests for different components of fitness. This is the main part of this video. We're going to look at the test protocol, the equipment required, how to administer safe and effective tests, how to use correct units of measurement and suitability for different types of sports, performers, and fitness levels. So, flexibility tests, there are 4 tests you need to know. We're going to go through them in detail. So I would recommend writing notes for this. So first we have the sit and reach test. This measures hamstring and lower back flexibility. The equipment you need is a sit and reach box, which can really just be any box. You want to have a ruler or a tape to measure length of the stretch, and ideally you want to have an assistant. So the outcome of this test is measuring the distance reached, which is usually in centimeters. And key reliability considerations to take into account are having a consistent warm-up, consistent foot placement on the box, and no bouncing. Next, we have shoulder flexibility test. This measures the range of movement at the shoulder area or the shoulder girdle. This is often done with a broomstick, or there are other variations as well. When you're monitoring this test, you want to watch out for any compensation. So watch out for spinal extension or twisting to try and cheat the movement. Next, we have calf flexibility, and this is usually linked to ankle dorsiflexion range of movement, which is important in movements like running mechanics, squatting, and landing. And for this test, you want to stop immediately if there's any Achilles pain. Next, we have trunk rotation. So this is basically just turning side to side and seeing how flexible someone is in that movement. So basically measuring rotational mobility, which is important in sports like tennis, golf, and boxing. Now let's move on to strength tests. Strength tests, there are 3 main tests you need to know. The 1 rep max test measures maximal strength, and this is measuring the maximal amount of weight or load that can be lifted once with the correct technique. So some safety rules to think about are qualified supervision. You want to have spotters. You want there to be strict technique, and you want to stop the test if the form starts to break. As we previously mentioned in this video, 1 rep max tests are actually more suitable for trained performers, not really for beginners, because it can be really risky. Next, we have the grip dynamometer test, which measures hand and forearm strength. The units of this test are usually in kilograms, and the protocol is very simple. Take your dominant hand, squeeze the dynamometer, record the max measurement, and repeat 3 times, and then use the highest score of the 3. It's really good because it's quick and it's low risk, but it's not really sport specific for a lot of sports. And we have 7-stage abdominal strength test. As you could assume, this is for abdominal strength, and it works in progressive stages of abdominal movement that get more and more difficult as you go up in stages. The reliability on this test depends on having strict criteria for what counts as a completed rep with correct technique. Okay, now let's look at aerobic endurance tests. So there are actually 5 tests you need to know for aerobic endurance. We're going to start with the multi-stage fitness test, or the MSFT. This can also be known as the bleep test. So this measures aerobic endurance by estimating VO2 max. And the way it works is through levels or different shuttles, and each shuttle has a score, and the score is used to predict the VO2 max. However, there's a big reliability issue with this test because of the surface, the footwear, the turning technique, and the motivational levels, which can all vary in different contexts. So one person might do a bleep test outdoors, another might do a bleep test indoors. So it varies. Next, we have the VO2 max test. This is a lab-based maximal oxygen uptake test. So because it's in the lab under strict conditions, it's very valid, but it lacks a lot of practicality. So for example, you probably wouldn't have this in a school because of the equipment needed and the expertise needed. Next, we have the 12-minute Cooper run test. So this test is very straightforward. It's just run as far as possible in 12 minutes and measure the distance, which is measured in meters. There's also a 12-minute Cooper swim test, which isn't as relevant for this course, but if you still want to learn about that, check out the more detailed video I made going through all of these tests step by step and actually drawing out how each of them are conducted. Next, we have the Harvard step test. So this is where you step up and down on a 45 centimeter bench for 5 minutes at around 30 steps per minute. This test links aerobic fitness to heart rate recovery. So you need to have consistent timing and a heart rate measurement method. Next, we have the Rockport walk test. So this is where you walk 1 mile as fast as possible, record the time taken and heart rate, and then estimate VO2 max. It's often more suitable for lower fitness individuals more than for maximal running tests. So a sprinter wouldn't really need to do this. Next, let's look at speed tests. So for this spec, there are several distances of speed tests that you need to know. There's a 20 meter, 30 meter, 40 meter, 50 meter, and 60 meter sprint or speed test. And the main output of these tests is the time it takes to sprint over that distance. So the key reliability variables are having a consistent start, the same surface to run on, and a consistent timing method. And speed tests are great for invasion games and for sprinters, but obviously less relevant for endurance athletes. Next, we have muscular endurance test. So for this course, you need to know the 1 minute press up test, 1 minute sit up test, and the wall sit test. So the output of these tests are the amount of reps that you can do in 60 seconds for the 1 minute press up and sit up test. And for the wall sit test, the output or the outcome you're measuring is the time held in that wall sit position. So for this test, you want to make sure that the strict technique is being used. Make sure that there's consistent counting of reps and there's a consistent depth range to ensure that the test is reliable. Next, we have body composition test, and there are 4 tests for this that you need to know for the spec. One, we have skin fold test, which is where you estimate body fat using calipers at specific sites on your body. The reliability of this test depends heavily on the skill of the tester and also that there is a consistent site measurement. So if your skin fold is being taken from the stomach, you want it to be consistently from the stomach. You don't want to be changing from the stomach to the legs to the arms. Next, we have the BIA or bioelectrical impedance test. This estimates body composition using electrical resistance. So it's very sensitive to hydration status. Therefore, the reliability of this test can drop if hydration isn't controlled. Next, we have BMI test. So BMI, the formula for measuring BMI is mass in kilograms divided by height squared, which is meters squared because height is measured in meters. And like we mentioned in the previous video, BMI measurements are more useful for general screening, not really for specific athletes because their muscle mass can skew the measurements. So if you are using it for athletes, you want to combine it with other measures. Next, we have girth measurements. So this is measuring the waist, hip, and limb circumference, and it's useful for tracking changes over time. So if you're measuring the same waist circumference over the space of a year, you can see the changes. Next, we have the agility tests. So there are two main tests you need to know for agility. One, we have the Illinois agility run, which requires sprinting, turning, weaving around cones. And this is really good. So many sports you can think of, not just basketball, football, but rugby, even tennis, and so many different sports. Next agility test is the T test. So this is where you sprint forward and then laterally shuffle and then you backpedal. So again, if you want to see all of these tests being broken down in great detail, check out the other video I made. I didn't want to add all of it in this video because it would be too long. Next, we have balance, and balance can be tested using two tests. We have the stalk stand test, which is where you hold yourself on a single leg position for as long as possible. And next we have the beam walk. So this measures dynamic balance, whereas the stalk stand test measures static balance. And for the beam walk, you control your movement as you walk across a narrow surface. Next, we have coordination, which can be tested using a wall toss test. The wall toss test measures hand-eye coordination. So you throw a ball, a tennis ball or anything towards a wall, and then you catch it back cleanly. And the outcome of this is counting the successful catches in a specific period of time. Next, we have power, which can be measured using three different tests. One, we have the vertical jump test. So this is basically what it says. You mark a point on a wall or on a surface somewhere that you can measure, and then you jump from standing as high as possible, and then you mark that second point, which is the highest height that you jumped to, and then measure the difference in distance from the first point you marked to the highest point you marked. Next, we have standing long jump. So this is jumping horizontally from a crouch position and measuring the distance that you jump. Next, we have the Wingate test. This is mainly for anaerobic power, and this is where there's a 30-second all-out cycle effort with resistance being applied. And the power output, or the revolutions of the cycle output, is recorded in 5-second intervals across the 30 seconds. So this is a very specific specialist-based test. So it won't really be practical in a school, for example, because it's more likely to be based in a lab. Lastly, we have reaction time, and reaction time can be tested with the ruler drop test. This is where the tester would drop a ruler without warning, and the participant tries to catch the ruler. And the distance fallen before they catch the ruler helps to measure the reaction time. Again, if you want to see all of these tests in details with diagrams and illustrations and more in-depth explanation, don't forget to check out my other video. Okay, now let's look at what actually goes into planning a test. So step one is understanding the subject's requirements. So what sport or physical activity are they testing for? What's the age, gender, training age, and any injury history, medical conditions, and their current activity level. Step two, you want to select the appropriate test. And for each test, you want to justify with validity, reliability, practicality, and suitability, which we've looked at in this video. Step three, you want to have an appropriate sequence of tests. So a classic safe sequence or order is having having the non-fatiguing tests first. So like height, mass, girth test, skin fold test, and then go on to the speed and power tests like the sprints and jumps, and then the strength test next, if you are doing strength test, and then move on to the muscular endurance and the aerobic endurance last, because those tests would then fatigue everything else. Next step is the actual procedure of the test. So this is the demonstration, the instruction, and the practice trials. Step 5, health and safety. So this is the screening, the informed consent we talked about, and pre-test warm-up. So when it comes to actually administering a test, you need to know the responsibilities and the role of the tester. So the role of the tester is what you actually do. And what the tester does is they organize equipment and facilities. They motivate and prepare the client. So through things like warm-ups, consultation, pre-test procedures, and they maintain rapport while recording accurate results. The responsibilities of the tester: they observe technique and they enforce good standards, and they adjust the test for the client's needs, and also they ensure that the test is suitable for the client's age, their sport, and their fitness level. Now, lastly, like you're going to see with a lot of the units in the BTEC course, we're going to look at evaluation and feedback. So for evaluation and feedback, first you want to look at producing a fitness profile. So the fitness profile should include the tests that have been used and why those tests were suitable, the results of the test with the correct unit, what each test result suggests, so the strengths and the weaknesses, and how that impacts performance in their sport, and also the priorities for improving. When you're producing a fitness profile, you want to compare the test results to normative data. So normative data is data from peers, from sport performance, from elite athlete norms, and from accepted health ranges. Next, you want to provide feedback. So great feedback starts with a quick overview. So this is the big picture, and then highlight 2 or 3 strengths while giving evidence. Also highlight 2 or 3 priorities, also with evidence, and give clear recommendations. So what to train, how, and why. And you always want to end with an action plan and the date for the next test. So an example of a high level top grade recommendation, you could say something like, to improve a 30-meter sprint performance, use 2 sessions per week of acceleration training. The acceleration training could be 6 to 8 reps of 20-meter sprints from a consistent start position. Allow for full recovery in between each rep, so 2 to 3 minutes of recovery, and focus on powerful first 5 steps when sprinting. And then retest in 4 weeks to evaluate your progress. That's a great recommendation. That's great feedback that will give you high marks. Okay, that's it for Unit 5. See you in the next video.